Welcome to HansonMath.com videos. Here is a video on solving a system of equations in 3 variables using matrices and specifically using Gaussian elimination to put the system into row echelon form. So here you will see we have 3 equations. We have row 1, row 2, row 3. And right now it's in a regular system form. We have 3 variables, x, y, and z, and we have the answers in a column to the right. What I'm going to do now is I'm going to erase the variables. So what that will do is that will create an augmented matrix, if you will, and we can do row operations on it to try to put it into a format that will be helpful for us. So now, instead of the regular system, now if I just put some brackets around it, we'll have it in an augmented matrix version. Okay, so based on what we've been learning, row 1 is to contain x, y, z, and the constant answer information. So I can write that over here in my answer matrix. So we've got 1, 2, 1, -4. But right now, row 2 is not in good shape. We want the x variable to be eliminated or drop out. So we really want a 0 here. So what would be one way we could get a 0? Well, 2 would 0 out or be eliminated with a -2. If I have a -2 right here and I add row 1 and row 2, this would be eliminated. So what we'll do is we'll take row 1 and we'll multiply the entirety of the row by -2, and that will create a new row 2, which I will put in orange. That'll create a new row 1. So -2 times 1 is -2. -2 times 2 is -4. -2 times 1 is -2. And -2 times -4 is +8. Okay? So now I'm going to cross this out so that you don't get confused. So now what we're going to do is we're going to take our new row 1, we're going to add that to row 2 so that we can get a new row 2, and I'll put that right here. Okay, so here we go. -2 plus 2 is 0, which is what we want. We want this x to 0 out in row 2. -4 plus -1 is -5. -2 plus 1 is -1. And 8 plus -4 is 4. So right now, row 1 is perfect. It has x, y, z answer. Row 2 is great. It has no x, y, z and answer. And now we have to work on row 3. Row 3, we need this to 0 out and this, but let's just work on one thing at a time. So let's go back a little bit here. Let me erase some things for clarity. Okay, I'm going to get rid of all this. And I'm going to get rid of this. And I'm going to get rid of that. Okay, so now let's work on row 3. On row 3, we want this to 0 out. Well, how can we do that? One way to do it is if we have the opposite number of 1, which is -1 up here, and we add row 1 plus row 3, if this were -1, this term would 0 out. So we will multiply the entirety of row 1 by a -1 to create a new row 1, which I'll put right here underneath. -1 times 1 is -1. -1 times 2 is -2. -1 times +1 is -1. And -1 times -4 is 4. So I'm going to cross this out. And now we will add the new row 1 to row 3. -1 plus 1 is 0. It's just what we want. negative 2 plus 3 is 1. Negative 1 plus negative 1 is negative 2. And 4 plus a negative 7 is negative 3. Okay? That's looking great. Now, we're almost done, but we just have a problem. We want a 0 here as well, so that we have an answer of z equals something. So how can we get this 1 here to 0 out, if you will? Well, negative 5 right here would cancel out perfectly with a positive 5. So I'm going to multiply all of row 3 by 5, and I'll write the new row 3 down here. 5 times 0 is 0. 5 times 1 is 5. 5 times negative 2 is negative 10. And 5 times negative 3 is negative 15. Now, I'll cross this out. Now I'm going to add row 2 to my modified row 3, and I'm going to put the answers in a new matrix below. So I've got 0 plus 0 is 0. Negative 5 plus 5 is 0, which is what we wanted. Negative 1 plus negative 10 is negative 11. And 4 plus negative 15 is negative 11. Okay, now this is what we wanted. We have 0 for x and 0 for y. What I'll do next is I'll recopy row 1 and row 2 into our final matrix. We'll do a little bit of cleanup, and then things should be good. Okay, the only thing we need to do now is, let me clear some space out over here real quick, as quickly as I can erase on my tablet. Okay, the only little thing that we need to do here is this matrix here is not simplified as we'd like it to be, because we really want a 1 here so that we can have 1z or just z equals something. So what we will do is we will multiply row 3 here, or multiply everything by negative 1/11. If we do that, this will become a 1, and by coincidence, this will also become a 1. So what I'm going to do here is I'm going to write a new matrix up in the upper left, like this, and row 1 is 1, 2, 1, negative 4. Row 2 is 0, negative 5, negative 1, 4. And now if I multiply through by negative 1/11, which is really like dividing by a negative 11, essentially, I've got 0, 0, 1, 1. Okay, so this is our matrix in row echelon form. So now how do we get our solution or our answers? Well, let's do it. We know here this is worth 1z, so z is equal to 1. And now we'll back substitute into row 2. Row 2, we have 0x, we have negative 5y minus 1 times z, but z is worth the 1 we just found, and that equals 4. So if we solve this, we have negative 5y minus 1 equals 4. Adding 1 on both sides, we've got negative 5y equals 5. And then dividing both sides by negative 5, we have y equals negative 1. So now we have z, we have y. Now we just have to find x, which we can use by going to row 1. Row 1 says that we have 1x plus 2 times y, y being negative 1, plus 1 times z, z being 1, and that equals negative 4. So now we have x, 2 times negative 1 is negative 2, negative 2 plus 1 is -1 equals -4. Now we add 1 to both sides. X equals -3. Okay? That solves our system. So if you want to write the final answer in a triple ordered pair, actually that's nonsensical. It can't be a pair if it's a triple. It's an ordered triple. So the solution is -3 for X, -1 for Y, and 1 for Z. That is the solution to the system, which we placed into the system. We originally took the system, put it into an augmented matrix, and then we solved it using Gaussian elimination. I hope this helps. Thank you for watching HansonMath.com videos.